This is one of those stories that just blows your mind. It's about two identical twins. They were launched back in 1977 for what was supposed to be a 5-year mission to Jupiter and Saturn. But now, almost half a century later, they are still going. They're the most distant objects we've ever sent into space, the only ones operating in the vastness between the stars. This is the incredible 48-year epic of Voyager 1 and Voyager 2. Okay, so let's get right into it because the whole mission was built on this absolutely brilliant choice. These two probes, they look the same, but they were given totally different destinies before they even left the ground. Think of Voyager 1 as the sprinter. It was built for pure speed, aimed at a really high-risk, high-reward goal, and it was always meant to become our fastest and farthest messenger. Then you have Voyager 2, the marathoner. It was sent on a slower, longer path that would give it the incredible, lonely honor of being the only spacecraft to ever visit the ice giants, Uranus and Neptune. But this is where the story starts, with a fantastic little riddle. If Voyager 1 was the sprinter, the one designed to be faster, then why on Earth did the marathoner, Voyager 2, launch a full 16 days before it? It seems backward, right? Well, this wasn't a mistake. Not at all. It was actually the very first move in a brilliant, long-term strategy. And here's exactly how that strategy played out on the timeline. On August 20th, 1977, Voyager 2 lifts off, taking a slower, more scenic route, you could say. Just over 2 weeks later, its twin, Voyager 1, blasts off on a much more direct, high-speed path. And the plan? It worked perfectly. By mid-December of that same year, the sprinter had officially overtaken its twin, taking the lead on the way out to Jupiter and Saturn. So why all this complicated launch timing? Well, the entire strategy, this whole intricate dance, it all hinged on one single, crucial, high-stakes objective for our sprinter, Voyager 1. It was a close flyby of Saturn's huge, mysterious moon, Titan. This was what they called the Titan Gamble. And this was just a masterclass in managing risk. It was all designed around a planetary alignment that only happens once every 176 years, the key to the Grand Tour. So, step 1, launch the marathoner, Voyager 2, first. Get that precious, irreplaceable trajectory safely on its way. If that launch had failed, no problem, they could have just re-aimed Voyager 1 to take its place. Step 2, Voyager 2's launch is a success. Great, now Voyager 1 is free to go for it on its faster, riskier path. Step 3, Voyager 1, the sprinter, gets to Saturn first and attempts that all-important Titan flyby. And that was the linchpin. If it succeeded, its own tour of the planets would be over, but it would unlock the Grand Tour, clearing its twin to continue on the long road to Uranus and Neptune. The whole opportunity rested on the sprinter's shoulders. But before that big gamble at Saturn, Voyager 1 had its date with Jupiter, and while it found new moons and the planet's faint rings, its most revolutionary discovery wasn't planned at all. It was a complete accident, found 4 days after the main encounter, on an image that was considered low priority, basically an afterthought. So you have this navigation engineer, Linda Marabito, and she's processing this really overexposed picture of Jupiter's moon, Io. She cranks up the contrast just to see the background stars, and suddenly, there it is, this gigantic umbrella-shaped plume erupting hundreds of kilometers from the surface. It was a volcano. An active extraterrestrial volcano, the first one we'd ever seen. That one single accidental find completely changed how we think about worlds in our solar system. All right, then came the moment of truth at Saturn, the Titan flyby. And honestly, it was a tale of two outcomes. On one hand, it was a huge disappointment. The powerful cameras, they saw nothing. Just a hazy, featureless orange ball, totally hidden by smog. But at the same time, it was a massive triumph. The probe's other instruments, especially its radio, they pierced right through that veil, and they revealed a world with a thick nitrogen atmosphere, kind of like ours, and surface pressure 1.5 times what we feel here on Earth. Voyager 1 had done it. Its job exploring planets was over, but it had officially cleared the way for its twin. And just like that, the baton was passed. The sprinter's race was run, and now the marathoner, Voyager 2, began its long, lonely journey into the deep outer solar system, now officially on the Grand Tour. The first stop on this new leg was Uranus, a planet we knew almost nothing about, and the engineering challenge here was just immense. The key number you need to know is 900. The sunlight way out at Uranus was 900 times fainter than what we get here on Earth. To get any clear pictures at all, engineers back at JPL had to figure out how to remotely reprogram this 1970s computer from billions of miles away, basically teaching it a new trick: pan the camera during long exposures to keep the images from smearing. It was incredible. And what our one and only visitor found was a truly strange world. From the outside, Uranus looked kind of bland, just a pale green orb. But underneath, it was just bizarre. It had what scientists called a crazy magnetic field, tilted by a whopping 55 degrees and way off center. The probe found 10 new moons, 2 new rings, and it had to do all this while approaching the planet, which is tilted on its side, like a dart flying toward a dartboard. The team could only get a close look at one of Uranus's moons, and they chose the smallest one, Miranda. And what they saw was one of the weirdest things in the entire solar system. It looked like a Frankenstein moon, a cosmic jigsaw puzzle that had been smashed to pieces and then just carelessly slammed back together, with canyons 12 times deeper than our Grand Canyon. So after a final spectacular visit to Neptune, where Voyager 2 discovered the Great Dark Spot and actual geysers erupting from the moon Triton, the planetary mission was officially over. But a brand new mission was just beginning for both of our probes: the race to become the first human-made objects to take that first step into the vast ocean of interstellar space. Okay, so this is where our tale of two twins really comes full circle. Look at this. Voyager 1, the sprinter, did its 2-planet tour, and sure enough, it was the first to enter interstellar space back in 2012. Voyager 2, our marathoner, visited all 4 gas giants and crossed that same boundary 6 years later. But here's the crucial difference, the little twist in the story: one key instrument. Voyager 1's plasma sensor had failed years ago, but Voyager 2's, it was still working. And that changed everything. And this led to this just beautiful, perfect irony. When the faster twin, Voyager 1, crossed that line, scientists couldn't be 100% sure. With its main sensor dead, they had to wait for a blast from our sun to make the plasma around the probe ring like a bell, proving indirectly where it was. But then, 6 years later, along comes the slow and steady marathoner. And its working sensor? It gave us the first ever direct measurement of interstellar plasma. It gave us the ground truth, and in doing so, confirmed its twin had been right all along. And just trying to keep these probes alive today is an almost unbelievable feat. I mean, Voyager 1 is over 15 billion miles away. So this number, 47 hours, that's the round-trip time for a radio signal. Imagine typing a command to a computer with less memory than your car's key fob, hitting send, and then having to wait nearly 2 full days just to find out if it even worked. And that insane challenge became very, very real in late 2023. Voyager 1 just started sending back total gibberish. The diagnosis? A single, tiny, corrupted memory chip. The solution, though, was nothing short of a miracle. From 15 billion miles away, the team at JPL performed what you can only call interstellar brain surgery. They digitally chopped up the broken code, carefully tucked those pieces into other scattered working parts of the memory, and then rewrote the main software to know where to find all the new fragments. And then they waited for 47 agonizing hours. And it worked. Voyager 1 was back online. But you know, beyond all the incredible science, the Voyager mission has always had this other side to it, a deeply human element. It wasn't just designed to be an explorer, but also a messenger. See, bolted to the side of each probe is the golden record. It's basically a message in a bottle thrown into the cosmic ocean. It's this incredible mixtape of humanity with 115 images, sounds of wind and whales and laughter, greetings in 55 different languages, and 90 minutes of music from Bach all the way to Chuck Berry. But here's the real secret of the golden record, and I absolutely love this. The people who made it, led by the great Carl Sagan, they knew the chances of it ever being found by aliens were tiny. So they actually designed it for 2 audiences. And the most important one wasn't some distant civilization, it was us. The record was this profoundly hopeful act, a statement to the people of Earth about the best of who we are, a symbol of what we could achieve when we worked together. And speaking of Carl Sagan, he was also the driving force behind the mission's other great human artifact. Way back in 1990, long after Voyager 1's main job was done, he pushed NASA to do something crazy: turn the cameras around one last time and take a picture of home. It was risky, it served no scientific purpose, and the request was almost denied. But Sagan insisted. And this is what it saw. Our entire planet reduced to a tiny point of light, less than a single pixel, caught by chance in a ray of scattered sunlight. Sagan knew that the profound lack of detail was the entire point. As he so famously said, "Look again at that dot. That's here. That's home. That's us, on a mote of dust suspended in a sunbeam." It's become one of the most powerful images and reflections in all of human history. So where are they today? The twins are still sailing on. Voyager 1 is now about 169 times the distance from the Earth to the Sun. Voyager 2 is a little behind at 141. But their nuclear batteries, their hearts, are fading, losing about 4 watts of power every single year. And soon, maybe in the next few years, their instruments will have to fall silent forever. But even when they go quiet, their mission will never truly be over. They're going to drift on through the galaxy for millions of years, these silent ambassadors carrying our mixtape and our memory into the void. And it leaves us with this one last thought. What is the real, lasting echo of these amazing probes? Is it a message to the cosmos? Or is it a timeless message to ourselves about the curiosity, the ingenuity, and the hope that represents the very best of us?